So now we can go back to the worksheet, limiting reactant worksheet 1. So this one, the number 1 is determine the LR and ER. So as we say before, my LR or limiting reactant are the ones going to be used up first in the reaction, and the ER or excess reactant or the reagent is going to be the one left over after reaction. They both call reactant. That means they should be on the left-hand side of the equation. Now, this worksheet, this front page is talking about how do I find out which one is LR, ER from moles. Okay, we're going to use mole to mole relationship. So how do I find out LR, ER? So first, you want to write out a balanced equation with the coefficient, and then I can find the MR. And then you want to imagine my A is the bread, B is the meat, and D is the hamburger. So from how many pieces of bread, I can figure out how many maximum hamburger I can make. So you want to use mole. From bread, I find the mole of hamburger. And then I will also using the meat. I from the moles of meat, I can figure out how many moles of hamburger. You want to compare these two hamburger number. Which one is the smaller number of hamburger? That will be my theoretical yield, meaning the maximum yield that can be made. Maximum product, maximum hamburger I can make. Okay? So this is one thing I can determine how many maximum yield I can have, how many maximum hamburger I can make. And then last part is if the bread will give me less number of hamburger, right? If the A give me less number of D, then my bread or the A will be LR, limited, because it's going to be used up first. And then the meat in this case, the meat give me more hamburger made, the meat will be ER, meaning the meat will be left over. And then here is like opposite direction, opposite relationship, opposite situation. Okay, so let's look at the example here, right? So iron 3 chloride react with oxygen to produce iron 3 oxide and chlorine gas. So how many moles of chlorine can be produced theoretically, meaning maximum yield, if I give you this amount of reactant and that amount of reactant? So first, it looks like that all the product have been given to you, okay? So we are going to write out the equation, okay? We're going to write out the equation. And then we write down what we have and what we're looking for. That's part A. And then part B, we want to figure out how many, from how many bread to how many hamburger I can make. So how many FeCl3 to make how many moles of Cl2. So we're going to use the mole-to-mole ratio thing, all right, mole-to-mole ratio, molar ratio, to find out, okay, I can make 6.75 moles of Cl2. And then here will be from how many meat will make how many hamburger. So from how many oxygen will give me how many Cl2. So we do the same thing for molar ratio. From the oxygen, I can find out, okay, I can get 8.00 moles of Cl2 I can form. You compare these two numbers, 6.75 hamburger, 8 hamburger, which one's smaller number? Okay, this is the smaller number. That means this is the maximum hamburger I can produce. This is the maximum Cl2 I can produce. So this is my answer for part A. Part A asks you how many moles of chlorine can be produced theoretically. So we're going to continue to write the sentence. 6.75 moles of Cl2 can be produced theoretically. So that's my answer for part A. And then here, 8.00 mole of Cl2 will never take place because I don't have that much of bread. Okay, so this will not happen, so we just leave it like that. And then from the theoretical yield, we know that, okay, since this is the maximum hamburger I can form, which one ingredient would be left over will be FeCl3. FeCl3 will be my LR, limited, right? So then we can answer the part B answer. And then this one will, O2 will be my leftover reactant, excess reactant. Now, let's look up the example 2. 3.4 moles of nitrogen can react with 4.85 moles of hydrogen to form ammonium gas. So we first write out the equation with the state, balance them, 1, 3, 2, and we write down the information on the bottom. That's part A. And then part B, we got to write, right, from N2, how many NH3 we can form. We do the supplement, and we find out 6.90 mole NH3. And then here, from how many H2, we will produce how many NH3. So we also do the same thing from mole-to-mole ratio. We found out that I can produce 3.23 moles of NH3. They're both hamburger, they're both product. We compare these two numbers. All right, this number is smaller, 3.23 smaller. So then this will be the theoretical yield I can produce. So we can continue to write the sentence, 3.23 mole NH3 will be produced theoretically, and we box that. This is the answer for part A. How many moles of ammonia will form theoretically? This is my answer. And this one will never take place, so we just leave it. And then from here, because this is theoretically yield, so which one will be used up first is the H2 will be used up first. So H2 will be LR. Because this number is smaller, that means H2 will be LR. This number is bigger, so that means the N2 will be left over. We have too much N2 left over, so N2 will be ER. So these two are the answer for part B. Limiting reactant is H2, N2 will be excess reactant.